Okay, we start our class today with the station of Umul Kitab Al-Fatihah. Okay, in the previous class we learned about fundamental force under electromagnetic. We basically want to focus on this EM, because EM what govern most of is the force that govern most of your everyday material. Gravity normally for the big stuff, and strong and weak force normally govern only at subatomic level. For example, how the proton and proton combine together. But we just later on we just touch a very little here, just like that only for the strong and weak. So our focus is on EM. So we learned before under the EM is that we have this magnetism. Previous class we learned about how this magnetism originate, and then we learn about this Coulomb law. We learn also how to calculate. We learn also about the static electricity, where all the material are made from the positive and negative charge, but because they are equal amount of positive and negative charge, then most of the material that you can see, for example you yourself, this pen or whatever around you is neutral. That's why you don't feel the attraction. But this what we call this charge inside your body can flow out. Okay, this charge, for example, inside this metal can flow out by what? By friction, by sometimes by friction, by charging. So we learn about this thing, electrostatic, how electrostatic can happen when you sort of like let me first close the Aiman, you need to mute. Okay, so we learned before that you can transfer charge by charging, and this charging can be done by friction. So when you sort of like make two things into contact, one material may have a tendency to what we call to give the electron away. So that's what we call charging by contact lah. So you can see previously when I have this straw, I rub against my hair, and then what happened is that the the negative charge in my hair flow into the straw. Okay, so when I do that, what happened when I put this straw, now when I do that thing, this straw having more negative charge. So we can say that the net charge is negative. So when you have this net negative charge, you put it near to the neutral tissue paper. Remember, this tissue paper is neutral. Okay, so what happened now when you bring this what we call this negatively charged straw to the neutral tissue paper, the positive charge will sort of like attracted to the negative charge on this straw, but this positive charge cannot jump. So what happened is that the positive charge will sort of like polarize, will align themselves in such a way that the positive charge will be nearer to this what we call this let me put here this thing lah, this negative charge region. So that's what make this paper will sort of like attach to what we call sort of like going to this plastic straw lah. So we learn about that, and also we see in your daily life this thing also can happen when you when you walk on the carpet. Okay, so when you walk on the carpet, so this carpet, the fur or wool or whatsoever, have more in terms of triboelectric series. They are more easily to sort of like what we call absorb the negative charge. So that's why when you walk through the carpet, the negative charge from your body will flow to the carpet. So now your body have not neutral anymore, sort of like imbalance. So your body now we can say like having the positive charge overall. So because of this imbalance, if you go near any metal, remember metal, they have something a little bit different, because the electron in metal, they are free. compare the electron inside this polymer, they are not free. One of the characteristic of metal is that the electron in metal is free to wander. Later we will go in detail how that's look, but this only happen when you go near the what we call near the metal knob. The electrical charge, especially the electron, will jump to the positive in order to balance out. Okay, and then when what we call from your hand, it goes to your body and then goes to the ground. So because the ground is the reservoir of the charge, so you ni lah, it's okay, it become balance, restored lah. But if you see here, this only happen when you not even touch lah. I mean that just near the metal doorknob. The key here is metal. If you have wooden doorknob from wood, then it doesn't happen lah, because the electron cannot jump there. Okay. Similarly, when you go to petrol station, the electrical discharge, the spark happen because the nozzle itself is made from metal. The spark happen between your hand and the nozzle, not on the handle. The handle is made from the rubber. That's why you go to the petrol pump, the handle is rubber to protect you lah, sort of like to protect you from the metal of the nozzle itself. So that's why when you go out from the car, before you pump the petrol, you try to touch the car first, because even though you have your self here, let's say I draw your self here, even though you touch the nose, the handle made of the what we call plastic, but remember the discharge can happen even though there are no contact, because this metal, they can jump. That's why you see the spark. So even though you what we call, you hold the holder, but then the nozzle still metal. So the electron from the metal can jump to your hand, and when it jump, the spark happen. Because of this spark, the problem is because when the spark happen, they are sort of like electric lah. So it will sort of like if there is a vapor there, for example, if there is a vapor of the gas, then the spark will sort of like ignite the vapor, and then they will be like what we call the fire lah. So that's why when you get out from the car, before you put your nozzle before you even touch the pump nozzle or pump handle, that thing, try to touch your car in order to ground yourself, because now when you are in car, you are sitting on the car seat, and then you move here and there is friction. When we said before friction, if let's say your car seat is something that can attract your negative charge, then when you sit, there will be imbalance in your in your body, because the seat sort of like capture some of the electron from your body. So when you go out, you are basically net positive. Okay, when you are net positive, then any negative can jump to you, especially from the metal lah. So that's why you touch the metal car, the hood or bonnet, in order to make sure that you restore the neutrality in your body. Okay, so the spark will happen far from the nozzle. So that's okay. If there is spark, even if there is spark, it's so far from the nozzle, and then it's safer lah. So that's what we learned in the previous class lah. Okay, in the previous class. Mana ni letak ni? Letak sini. Okay. So just recap lah. Okay, one more thing. We say whatever happened before, the one that this what we call this apa ni? This straw, and then you have what we call this neutral paper. This paper, straw, and then and also and also this thing, and then you walk on the carpet, and then you touch the what we call the door. Yes?
I'm here.
Okay. Nadila?
Yes.
Okay, you can open. So Sophia, you can go, but you still get 0.5 lah. Okay. What is Nadila? So I pin you. admin. Okay. So basically now, so we learn also this. There are doorknob, metal doorknob, and what else we talked before? We talked also about what happened when you coming up from when you want to what we call to put this in the petrol station. Let me draw this thing. Yeah, this petrol lah. So petrol gas lah, gas. So all this thing, people mention this is kind of electrostatic interaction. I just want to mention here that this static, the word static here doesn't mean that the what we call the charge not moving, because if you think about it, when they are discharged, for example, if let's say the electron jump from here or from here to your body, and also from here, this is not jump lah. In this case, straw and paper, the electron doesn't jump, it just polarize. But in case of this number 2 and number 3, the electron jump to you, we can say straight away that the electron is moving. So why they are static here? So the static here, it doesn't mean that the electron there are no motion. So don't electrostatic doesn't imply the charge is motionless. Okay, so it doesn't imply that charge is motionless, because after all the electron is always moving. Okay, it's just the term, it's just a convention only lah. So it's much better for you to sort of like to view static as so it's better to view static as imbalance in charge. Imbalance in charge. It's much better lah. It's much more accurate lah. Or it's much better when you talk about static, you talk about the net charge, rather than you thinking about the movement of something that is not moving. So it's just like a convention. It's just a convention. They call it electrostatic. Okay. So I say before, okay, if you look this number 2 and number 3, we can say that the what we call the electron jumping, is more pronounced in metal. And why is that so? Is because metal is a conductor. You know, metal is conductor. The reason for this is metal is conductor. Okay, what is conductor? Conductor, okay, because this you see the properties of metal lah. One of the properties of metal, one of the material that you learned before. One of the properties of conductor is that it permit the electron. It permits electron to move freely inside the atom. Inside the atoms. Meaning that, for example, let's say this aluminium, this is aluminium. Okay, inside this there are also atom, the aluminium atom. So we know the aluminium atom have what? The aluminium atom have this thing. You have, let's say, this is what we call, this is like proton, and then let's say this is a neutron. Right, this is neutron, and also you have what we call the electron, more or less not revolve, it's just cloud of probability, but for the sake of making easy, so I just draw like this. But in reality, the electron doesn't move in orbit. It's just like you cannot even see where is the electron. It just it's much more accurate to draw like this. It's much more accurate to draw like what is the thing? What is the like? It's more accurate to draw something like this. It's much more accurate to draw something like this. It's like a probability cloud. What does it mean is that the more accurate representation of how electron revolve the nucleus is that they are like a region, the what we call the probability region that is more favorable for you to find the electron. It's more probable. So this is the region for ni lah, for this thing. Okay, and this region is what we call the orbital. This region is called the orbital. You learned before that we have the SPDF orbital. This basically you should learn in your chemistry. They are orbital. We don't call about orbit. So orbital is just a region of certain energy lah. An electron can only reside on that energy level. Okay, for example, the s orbital, just to go a little bit further in orbital before I talk about this conductor again. So for example, the s orbital, you know, is like a sphere. What does it mean is that if you have the, what does it mean by this is that if you have, for example, the nucleus here, I draw the nucleus here like black and white like here, a neutron and proton, then the what we call the you can find the first electron, the first first nearest electron is in this region lah. For example, let's say let's talk about helium. Let's talk about the helium. Okay, helium only have one proton. They are no neutron. So for example, helium, you have one proton there, is positive, and then you can find the electron around it, meaning that if you have this thing, so I draw like this because as if you cut the ball into two. Cut ball into two. Let's say you have a ball and then you cut into two, so I see from the side, from the cross section. But this thing, the one that I draw dot like this, in 3D is as if like a perfect sphere lah, perfect sphere. So this just for you in 2 dimension, but in 3 dimension is a perfect sphere. So that's why this, when you cut this cross section, as if you have like if you cut cross section, you got something like this, right? Something like this. And then if you see from here lah, that's what it shows here. It shows here why they are hollow in the middle, because you have the what we call the proton there, the nucleus in the middle. That's why it's hollow. So the what we call the electron can be found only at this region. It cannot be found here. It cannot be found here. 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 So electron can only reside there. Okay, not anywhere else. So that's the basically the thing. And if you see the p orbital, okay, the p orbital is something else. The shape is not like this. The shape for p orbital is like what? Like dumbbell, like this. Okay, so you have something like this, you have something like this, and you have something like this. So this, if let's say you have what we call this thing. So let me draw like this. So this is that. So it just to show that okay. So it just to show that this is x. This is x. This is y. This is z. Meaning that for the p orbital, you have what we call the shape for where the electron can reside is something like this, like dumbbell shape. Dumbbell shape. So meaning that the electron, if let's say they are, so basically the orbital will be look like something like this lah, something like this. It's like a lobe, L-O-B-E. It's like a lobe, or dumbbell lah. So it's like a strange kind of region lah. It's like dumbbell. So the electron can be either on the top, can be either on the bottom. Okay, it doesn't mean that the electron must be on the top, must be on the bottom. It can be either way. So that is where you can find the electron. Okay, and this is y and this is z. If you look here, the s orbital, you have only one sphere. It's like sphere. So this sphere, it can only accommodate 2. Maximum they can accommodate 2 lah. To what we call two electron. The maximum they can accommodate 2 electron. So you have up and down lah, up and down, something like this lah. Because we learned in the last class that the electron come in up and down. I think this also you learn in chemistry also, meaning that the maximum you can feel the electron inside this s orbital is 2. for this you have these three different we call it shell lah, these three orbital under one shell. So this, for this you can fill in up to 6. You can fill in 1, 2, 3, 4, 5, 6, meaning that if you have a p orbital, so this p orbital, maximum you can put is 6 what we call 6 electron. So that's what does it mean lah. And then D is something more what we call more pelik lah, lagi the shape complex shape lah, complex shape, I think like donut like that. So if you look here, maybe I just go here, it was easier for me. Let me show here. I think I just showed it before. So let me share orbital lah. You can see, right? So let me go image straight away. Okay, you can see that the orbital, so it's look like, let me put here. Okay, so if you see here, it's like a region. It's not like, it's more or less like this lah. It's like a region where you can find the electron. Where you can find electron is more stranger and stranger lah. So in 2D, in 3D, it's look like this, I think, like that. So it's like shear and so that lah. So meaning that here you can fill in the first orbital, you can fill in 2 electron. The second, they are 6. The third, 1, 2, 3. You kira lah berapa banyak tu. Okay, there are a lot of things. And this s orbital and so on, orbital in, if you go orbital in periodic table, you can see the periodic table itself. How to go? Oh no, close this thing first. Okay. So you can see that thing, you have this thing lah, SPDF there. Okay, you can have this SPDF, meaning that you have S orbital here, D orbital here, P orbital here, and F orbital here. So if you look at the periodic table, the PT table, let's say PT table here, you can see, right? PT table, let me go to the PT table here. Okay, if you look at hydrogen, if I click hydrogen, if you see here you can see this right one here, meaning that you have 1 electron only. So this 1 electron is at S orbital, because if you look here, there are S orbital there. This S, so meaning that 1 electron, they reside in probability region, looks like the sphere. So that's what does it mean. And then if you go to number, let's say you go number 2, helium, you see there are 2 orbital, there are 2 electron. So there are 2 there. So here, this 2 here. So this meaning that 2 electron. 2 electron there. 2 electron. If you go to 3, something different. You have this 2 and then you have 1. Okay. So meaning that you have 2 electron in the first S orbital, and then the second, and the other electron in another S orbital. Understand or not? This is not P yet, because the first region here is only S orbital. What does it mean by lithium here? Let me draw here. What does it mean by lithium? How you want to find the electron is like this. For lithium, so I go down. So let me go down. Let me put here. So for example, like lithium, you have the what we call 3 electron, 3 electron, more or less like that. So what does it mean is that you see in the middle, you have the proton. Let's say proton, I do like this. Okay, proton, and then also you have 3 neutron. So you have 3 neutron, because the proton and electron need to be equal number in order for the element to be what we call neutral. So you have this, let's say this is what we call proton. There are 3, and this is neutron. And in terms of orbital, so the first, what we call the first 2 will stay inside this region. So you can find, let's say I put the yellow and as not yellow lah, like blue, as where you can find the electron. But the electron is not like this. It's just to show you that there are 2 electron will reside in this probability cloud. So the second orbital, meaning that it's still like a sphere, but it's bigger. That's what does it mean lah. It's bigger, but it's still like this, still like probability cloud. So if you look here, they are like a gap here. If you look here, they are like a gap here, right? Like a gap, meaning that the electron cannot stay in between. They must be in the orbital only. So the third electron will be found here, will found there, will be found in the outer s orbital. Okay, so that's how the electron ni lah. So that's why the when you make it simple, you see something like this lah, something like this. Okay, something like this. I mean, when you learn in the high school and so on, normally they draw something like this. It much simpler lah. Okay, so that's about lithium. If you go further, so because now I go into this thing, into this periodic table a little bit. So if you go, let's say carbon, let's say carbon here. So carbon, you have 2 and 4. Okay, but remember, carbon here, you have what we call, even though carbon in the p orbital, if you look here, carbon here in the p orbital, but remember, the first electron, if you have 2 and 4, the first 2 must be in the s. It doesn't mean that all this in the p orbital, because you need to understand the energy start with the lowest energy, high, and even higher. So the lowest energy is the s orbital. So the carbon, the first two what we call the electrical configuration for the carbon is 2, 4, meaning that the first 2 in the what we call in the in the s orbital, and the third the 2, and then the 4 in the p orbital, because you have p orbital here, you have p orbital here. Okay, so let's go to here. So this one s, because do they have the electronic configuration here? I don't remember. Electron. Okay, you can see this configuration. Okay, so if you go here, and if you go to, oh dia ada dah, kan dia tak ada, dia dah ada, senang lah. Okay, you see here, hydrogen, you have 1s1, helium, oh dia bawa helium ke sini. You see, helium, when you talk about that, they bring the helium here, to make things easy. That's why helium there. So terubah. Okay, so 1s2. Okay, so here, if I look here, so you see the helium there. Can you see the helium over there? The color is red. The color is red. So the helium here, even though the region is p, but the helium is s orbital, still s orbital. That's why they bring the orbital there. So that's why the helium 1s. Lithium, you can see the lithium there. You nampak tak? Nampak kan? Saya harap you nampak kot. Okay, so you can see the lithium, the electronic configuration is 1s2, 2s1 here, meaning that the first level, the first orbital, the first s orbital is filled with the what we call with the 2 electron. The second orbital, which is bigger, still s, but it's bigger. So that's why you can see the red one and the blue one here. The red one, the small orbital, this is a 2s. This is 1s2 lah, 1s2, and then blue one is 2s1, meaning that 2 is basically the what we call the shell, is basically shell or orbital lah. Is 2 is bigger than 1 lah, so that's why you can see it's sphere, still sphere, because it's s orbital, but inside this blue sphere there are only 1 electron. So that's what does it mean. Let's go to carbon. If you go to carbon, okay, carbon, pelik ah. Nampak pelik tu kan? Okay, mana carbon ni? Saya nak draw pun tak erti. Tapi basically, inside that, okay, you see the dumbbell, but inside that they are 1s2, meaning that they are small s orbital near the nucleus. I mean the small one. You cannot see lah because they doesn't cut. Okay, but they are just inside. They just combine. It's not like yeah, they combine lah. So and then you have 2s2, 2s2 and then 2p2, meaning that the second orbital also the in the s region. So this thing 1s2 2s2 here, 1s2 2s2 here is like here, this beryllium. If I go to beryllium 4, I go to beryllium, it's like this. So this is 1s2 2s2, meaning that there are two sphere. One is small sphere, another one is bigger sphere. But the small sphere here, there are 2 electron. In the bigger sphere, there are another 2 electron. If you go to carbon also have something like this also. But inside this thing, inside this dumbbell. They are inside, you cannot see lah, tak nampak lah. So this, the one here, to show that the p orbital here is much bigger lah. So imagine they are small, they are sphere in the middle, but you cannot see. But here you have 2p2. What does it mean is that inside the dumbbell there are 2 electron. There are 2 electron, either up, either down, doesn't really matter. Either loop. Okay, so that's basically electronic configuration lah. What you learn S2, 1s2, 2s2. Have you learned this before in chemistry? This thing. Do you learn in chemical class? I mean the organic chemistry class, this thing? Haris? Have you learned this thing? Have you ever see this thing? 1s2, 2s2, 2p2?
Tak pernah nampak.
Pernah nampak? Pernah kan?
We learned during foundation.
So the foundation. So that's this thing. This orbital thingy here is very important because important in terms of chemistry lah. For example, if you look something like this, if you see something like this, methane, if you learn methane, if I show methane, when you draw 2D, you draw like this, right? You have C in the middle. Most of you will draw something like this, C and then H. Okay, but in reality, it's not like perpendicular. The molecule is not like that. The molecule of methane will be like in tetrahedral. Is something like this. Is something like, let's say I draw carbon in black, something like this, and then you have let's say I put red lah, something like this, and then they are like this, something like this, something like this. That's like methane. So what we call the angle is 120 something 0.9, if I'm not mistaken, something like that. So it's not like perpendicular, and the reason why this happen is because the methane, this is they assume the sp3 hybridization. Later lah mungkin, kalau if I sempat, I will explain this in the next class lah. But basically the reason why the methane not like this, perpendicular like this, but assume this, what we call the like pyramid or sort of like that, is because of the orbital. Okay, because of orbital thing. Okay, if you talk about this, if you always thinking about in this orbit, then you cannot explain how the methane behave like this. Okay, you need to talk in terms of orbital. Only then you can explain why methane do like this, why methane hybridize, why they are orbital hybridized. This hybridized orbital lah. Hybridized orbital just give you the idea. Hybridized means that is combined lah. So for example, this, you know this S, and then you have this thing, you have something like this, they hybridize, meaning that they combine each other. Normally, when I show something like this, it's not hybridized out. It's just you have small and then you have big. They are small one inside the big one. That is not hybridized. This is just like they just combine. Hybridized meaning that they sort of like, there are two things, they become something a little bit different. So that's hybridized. They just not add like that. It's just they have something that they hybridized lah. Later I will explain lah, but not in this class. So where we are, I talking about what? I talking about this. Suddenly become orbital. Anyway, so coming back from here, electron jumping is more pronounced in metal, what does it mean is that the electron in what we call in metal, if you see the metal periodic table, the electron in here, this metal, let me go back to properties. So the metal is here. When I click here, so this is metal, metal. When I click when I click like this, the metal here, so you see this is metal part. So this is metal part, this is non-metal, and this is metalloid. Okay, this is metal, this is non-metal, this is metalloid. Okay, in metal, the electron on the outer orbital, they are free to move. It's different than non-metal. In non-metal, they are not free to move. They are held in the with the nucleus. But in metal is quite unique. Is because the outermost electron in the valence shell, in the valence orbital, they are near with the conduction band. They are as if you view like this lah. For example, let's say you have something like this. Let's say you have something like this, and then you have something like this, and then you have something like this, and then they are a region called a conduction band. Somehow they are region called conduction band. Conduction band. Okay, so when the electron be in the conduction band, meaning that the electron is free to move. They are not attached to that atom. So for the metal, normally for the metal, the outermost electron and the outermost orbital, outermost valence shell, overlap with conduction band. Meaning that the outer orbital, if you have d orbital, the last orbital, they overlap with the conduction band. So when this thing happen, the electron sort of like can free to move, meaning that you cannot it's not attached to the electron anymore. Meaning that in this thing, you see here, you see this what we call metal, aluminium, whatever. So meaning that if let's say I have aluminium, let's say I draw like this, nampak kan? Saya malas nak kecilkan. So let me put here. If let's say this aluminium, let me put here. If this is aluminium, let's say I draw here. If this aluminium, if you go to the periodic table, let's go to aluminium. Aluminium, where is aluminium? Where's aluminium? So this aluminium, aluminium is still metal. You see, it's still metal. If I click metal here, it's still metal. So you look at the what we call at the this thing 283, meaning that there are three what we call three electron at the outermost lah. 3 electron at the
Valence electron.
Yeah, valence electron. Okay, so you have like 3 valence electron there. So these 3 valence electron, they can sort of like move here and there lah, because this valence electron they near the conduction band, somehow like that lah. So you have something, let's say the aluminium, let's say I have here aluminium, because inside the metal you have aluminium atom. I just draw like this lah, aluminium, let's say this aluminium, and aluminium, and then the electron is sort of like, imagine this, the atom, the atom, I just draw something like this lah. The electron, the 3 electron, I mean either 3 or maybe some, the one that is near the conduction band will sort of like be able to what we call to move out to let's say this electron like that. So you have these 3 electron, and because 3 electron, you have 3 to 1, 3, 1, 3. Yeah. So when the electron, because if let's say you have aluminium here, and then you have the outermost, I just draw the outermost, the outermost here. So for example, the inner one you have 2, the second one you have 8. 1, 2, 8 lah. Siapa ni? Lupa dah. 8 berapa? 8 2, 8, 3 So meaning that the second one you have 8. This Lewis diagram, the one that you learn in chemistry. And the third one, the outermost one is there are 3 1, 2, 3, somehow like that. Okay. In aluminium or any metal, when these 3 electron they move out, when this 3 electron, let's say this 3 electron, they move out. What happened to the aluminium atom? What happened is that aluminium atom will become 3+, meaning that they are, if let's say, because as I said in metal, this thing is it's free to move. So when this electron move away, then the atom will become not neutral lah, because now inside the aluminium atom you have the because if you kira ni, you have you have 1, 2, and then you have 2, 8 and 3, right? So you have 8 lah, you have 13 you have 13 electron in total. So meaning that in order to make thing neutral, in order to make aluminium metal like this neutral, you need also to have 13 proton, the one that is positive. So the proton inside the nucleus, so that's why you become neutral lah, so if 3 electron goes out, then the atom, the aluminium atom become deficient in electron. So that's you become A3 plus lah, Al3 plus. Okay, because when you have negative, that is for electron lah. So Al3 plus. So you have this thing, and because each electron atom is, so meaning this thing lah. So this is the what you call. Let me draw like this. Al3 plus. Okay. So meaning that now inside the metal, you should draw something like this. If I go down here, if you want to draw the configuration of inside the metal, it will be like this. Let me put like this. So it will be like this. So you draw something like this. You Al and then 3 plus. You draw like this, and then you have, let's say you have like Al 3 plus. Let's say I put only 3 aluminum atom only. I put 3 aluminum atom, 3 plus, meaning that the amount of electron that is moving must equal lah. So for example, 1 aluminum atom giving 3 free electron, so you need to draw the electron here, 1, 2, 3, and then the second aluminum atom also give the 3 mobile electron, so you have another 1, 2, 3, and the third aluminum atom here also give another 3 mobile electrons, so we have 1, 2, 3 like this. So this electron here, the one that is mobile here, they are free to move, and because of that you get electricity lah. When you connect with the battery, you get connect. Because of why? Because of this thing, we call it electron C model. You need to make sure when you draw this thing, you need to make sure the amount of electron correspond to the amount of the atom. For example, here you have 3 atom. You find the what we call the valence electron, because the valence electron is the one that can move. So if the valence electron is 3, so in case of aluminium, the valence electron is 3. So meaning that each aluminum atom will give 3 mobile electron. So if you have 3 in total, if let's say you have 1, 2, 3 atom, so the number of electron that coming out to the C of electron is 3 times 3 lah. So you get 9. So you need to make sure you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you draw the electron C model lah. In the metal. So in the metal it's like this. So there are no, in the metal you don't see the covalent bond and so on. You don't see the ionic bond, whatever. So in the metal it's like this. You have an atom, they arrange compact with each other. So if I may, ada gambar metal, let's say gold lah, gold, aluminium lah, aluminium TEM. TEM is just what we call the microscope, the electron microscope. So you can see if you look, tak nampak sangat ni. Gold lah, gold besar sikit, gold TEM. Bukan gold, EFM. Don't worry about the EFM, TEM, that thing. That's just I want just to show you that how gold looks like. Mana gold atom? Gold atom. EFM mean that they want to see the atom itself. So if you look under this whatever, is more or less like this. In metal, it's more or less like this. I mean, remember when you try to see under the microscope, this you see like this ball something like this, but this is like just a repulsive electric charge only. But at least you can see that in metal the atom is sort of like in a line, is in order. So if you look something like benzene is not like this. It's more like it's not ordered like this. When you talk about conductivity, inside this you need to view something like this. The electron is free to move. Okay, that's why the conductor, the electron, if you remember before, why when you go near the doorknob, sometimes they are discharge, spark happen, is because the electron is free to move. Okay, that's why if you have a non-wooden doorknob, then there are no discharge lah. Maybe they are just polarized only. But if you are nearing the metal, for example this metal, and then for example let's say my hand now is net positive charge, meaning that I am imbalanced, and then my hand is, there are a lot of positive charge, the negative charge from this will jump to here because of that thing. The electron is free to move. It's not like held together to the atom tightly like in the polymer. If I have this thing, even though my hand is imbalanced, positively charged, if I go near, there are no spark. What the most can happen is that this thing will be polarized. The way that when I take this straw, I put like this and go to near the neutral object like the tissue paper last time, the thing that can happen is that it just polarized, and if the polarization is good enough, it can attract lah. But it's not enough to create a spark. Okay, spark means that it's jump like that. Okay, so the electron is the one that jumping lah. Okay, so that's we talk a little bit about the metal lah. How the bonding inside the metal is like this. There are no like ionic bonding. There are no covalent bonding. It's just like a sea of electron. So we say this thing. We say this electron. We say this free moving electron. We have the name for that. The name, we call it delocalized. I mean, the more correct, the more what we call scientific jargon is delocalized electron. Okay, so we can say that metal have delocalized electron, mean that the electron is not stuck in one locality only. They delocalized. They can go here, and there. Okay, they are not bind to a particular atoms lah, because remember inside this there are a lot of atoms. Inside this there are a lot of atoms, like the one that you see, there are a lot of atoms. When you see something like a lump of metal or any metal, don't imagine there are only one atom. There are many atoms inside that. Okay, there are many atoms inside this thing. Okay, and then the electron just move around here and there. Okay. Okay, and the reason why they can move around is because this what we call the outermost electron overlap, the outermost orbital overlap with the conduction band. That's one way to answer also lah why they can move. That's one of the answer, because overlap with the conduction band. Okay. Okay, so one thing, any metal is good conductor, the same way, for the same reason, it is good conductor, good what you call, good put electrical conductor. For the same reason, it is also good in term good what you call, heat conductor. Okay, so any metal is good electrical conductor. So you know, electric is happen because of what we call the flow of electron. So that's why, and because the electron in metal is mobile, so that's why it can move. The reason why metal is good conductor is also the same reason why the metal is also good conductor lah. Good conductor, because the electron is loose. Okay, they can because yeah, the same reason, because the good heat conductor. Electron in other material like in glass, ceramic, and also in polymer like a plastic or rubber, they are tightly bound to the nucleus, to the what we call, belong to the particular atom. Okay, they are not free to move. For other metal, for other than metal, they are not free to move. Okay, so we call electron in other material, for example, in, let's say, polymer or in ceramic is not free to move lah, not free to move, and so that is a poor conductor in term of heat and also electric. Normally the good electric conductor also the good heat conductor. The poor electric conductor also poor heat conductor. Okay, because the reason is the same. Okay, so we call that insulator lah, that material insulator. So the term insulator, conductor, so metal is conductor because of this thing. Okay, whether the so now we can say that whether the material is conductor, this is the properties of material, whether a material is conductor or insulator depend how tightly the electron, how tightly the atoms bind the what we call, hold their electron, especially on the outermost valence shell lah, because it's far from the attraction, the electromagnetic attraction. So that's why whether it's conductor or insulator, it depend on that. So if you look here, if you look at the periodic table here, mana periodic table? This periodic table. Okay, periodic table. If I go here, if you look side here, you see here, they are conductivity. If you look here, they are conductivity. So if I go here, click here, you have thermal and electric. So meaning that it's more or less the what we call the sort of like not correlate. I mean the same thing. I mean not the same. I mean that the idea why is good electric, conduct electric and conduct thermal is the same. Conductivity is because of the electron. So if I click electric here, so and if I click here conduct, I just click here, you can see the color. You can see the color. Okay, so I click this thing, so you can see the color. So what you see here is that the darker the color, the better the conductivity. Okay, you can see, right? You can see. So you can see this. They are conductivity ke? Conductivity lah, conductivity. So you can see here there are numbers there at the bottom, 59, 62, 45. So meaning that the higher the number, the better the conductivity lah. So if you look here, I click at conductivity, right? So the unit is Siemens, whatever. Don't need to remember this thing, but just to show you, you can see the silver is the best conductor of all. which 62 what blah 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 lah, microsiemens, whatever that thing. And then the copper is the second powerful conductor. So that's why you can see a lot of copper when you have the wire inside the copper. They don't use silver because of course silver is expensive. Even though silver have what we call high conductivity, but silver is expensive. That's why they use copper. Copper is cheap. Okay, and then come the gold. Gold also good conductor. Okay, aluminium also good conductor, but lower than gold lah. And if you look here in the non-metal here, this is non-metal, you can see they are very very low. You see number at the bottom, right? To the power of -9, carbon 0.10. So it's very poor. But carbon you can conduct also. It's just low lah. And then you see this thing very low lah. This is so the non-conductor. But you see the metal, you can see the color. If I click the, instead of electricity, if I click the thermal, is basically the same. You can see if I click thermal, yeah, it's the same. Yeah, thermal. I click there, same. It doesn't change, thermal. But you see the number change, 400, 430, 320 like that. Okay, so copper 400, silver is the same trend. Thermal, this thermal, and I change the electric. So it doesn't really change the trend. The trend is the same. Silver is still the top and so on. Okay. About the electric, so I go to electric. About the conductivity, you see that the copper is one of the most what we call, give the highest electrical conductivity. The highest one is the silver lah. This Ag, but silver lah. Ag is silver, and the gold is the third highest conductor of electricity. But if you see any high end, or if you go to your phone, if you take your phone, they don't really use copper inside to conduct. Most of the time they use what we call gold, or even any electronic, your laptop, whatever. If you take out all this case and so on, the connectivity between this and that, normally they use gold. They don't use copper. But if you look here, the gold is lower in terms of conductivity than copper. Plus, the gold also more expensive. Then why people use gold inside electronic? This you can see, for example, during the Olympic, Tokyo Olympic, you know, right? The medal, the gold medal for the Tokyo Olympic is basically made from the refurbished gold metal that taken from the phone, right? This what we call, I think, the gold medal Tokyo Olympic. Okay, gold medal Tokyo Olympic, that thing. Blah 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 blah. This gold medal. So let's go from where. So I think they said from mana ni lambat. Okay. Material. Gold metal Tokyo Olympic material. Okay, you see here, you read there. This year medal, meaning that during the Olympic 2020 or 2021, the gold medal are materials recycled from electronic device donated by the people of Japan. Meaning that what we call the gold medal at Tokyo Olympic contain 1.2% gold, but basically the gold that they use is basically they take from the phone. They ask the what we call the community to donate their old phone, and then they take out the gold from that. So to show that, I tell this just to show that inside your phone, inside your electronic, they are gold. The pure gold lah. So the question here, why they use gold? Why don't they use copper? Because if you look, copper is cheaper, and copper is much faster, is much more conductive in terms of electric than gold. If you see here, copper is 59, gold is 45. So the reason why they use gold is because gold is non-reactive, is less reactive lah than the oxygen. Okay, if you have copper, for example, do I have copper? So if I have copper like this, if I have copper, this copper under the air over time they will be oxidized. So you get copper oxide, and also if the environment have sulfur, you get copper sulfate. Copper oxide and copper sulfate is not as good conductor than pure copper. Okay, copper oxide or copper sulfate or copper whatever is not as good as conductor compared to the pure copper. But gold, if you use gold, gold is less reactive than oxygen. So you don't have gold oxide whatever so on. So gold maintain as a gold. That's why people use gold. That's why the sister like gold, because gold is, and also people trade with gold because gold is not reactive. It's not really reactive lah. And also that's the same reason why you use gold as a teeth replacement, gold teeth, gigi palsu guna gold tu, because it's not react. Because it's not react, the gold maintain its own intrinsic properties, conductive properties. So that's why gold they use in this thing as conductive element, because it's not oxidized, and then the conductivity is not hindered lah. It not goes down lah. It's maintained like that. So even though the gold is expensive, the aurum here, the gold is expensive than copper, and also even though the gold have lower conductivity, electric conductivity compared to copper, but they still use gold because of the copper can oxidize. In the wire, they still use copper because you see in the wire they have this cable, right? They are shielding. They are shielded by the polymer. The wire kan ada polymer. Wire kan ada polymer. So tak kisahlah. So they are not exposed to what we call, you see the wire there, they are not exposed even though they use copper there. They are not exposed to the oxygen, something like that. So you see this, the blue one is the polymer. So the copper inside is not exposed. That's okay. But when you use you may say that this also not exposed, but yeah, this is, you can put a lot. There are a lot of, that's why it's expensive. One of the reason why they are expensive. Anyway, so that is about the conductivity and electrical conductivity and thermal conductivity lah. So basically today what we recap about this electrostatic. We also talk a little bit about this orbital, okay, and also we talk also about what make conductor conductive, okay. We learn also about this thing, the electron C model. So we call it electron C model. We also learn about how to draw the electron C model. We also learn about how equal the conductor and insulator is, conductor and in terms of heat, and also the electric is more or less the same. Whoever are better in conduct electricity also the same. Also they are better in terms of conducting the heat. We also learn what is insulator. And I think that's it for today. Today we have full class, because after this we discuss a little bit about your midterm. But before that, let's go to what we call this question time. Question time only for those who open the camera. Because we don't have time. So let me ask one thing. Okay, question time for those who open the camera. As usual, summarize. Question time for those who open camera. Tell you for 1%. Those who want to answer, please answer. Summarize what we learned today. Anyone? Let me make one note. Anyone?
Haris, sir.
Haris. Okay, Haris.
Okay. So today we learn about electrostatic. Uh, Electrostatic doesn't imply that charge is motionless. Static preferably imbalance in charge. And then we learn about electron jumping, and also we learn about orbital. There are four types: SPDF. S could fit 2 electron, P could fit 6 electron, and also uh, we learn about conduction band, where the outermost of valence shell overlap with it, and we learn about electron C model, and also a little bit trivia on Tokyo Olympic gold medal.
Again, your last, the last.
Last one.
What you say? The last sentence. The last sentence.
Oh, the trivia about gold is used inside the telephone, and also about the gold medal
So
in
why
Olympic.
people use gold in phone instead of copper?
Because it is less reactive than copper.
It's reactive. Okay, so thank you, Haris. So basically, today we are not we are not really much we learn, but at least it's important for you to know this what make the metal conductive, because one of the properties of the metal is conductivity. So you need to be able to explain why metal is conductive, why non-metal is insulative. So that's one thing. And you need to also know how to draw the electron C model. You need to get some glimpse on this, what we call the orbital. The orbital. What does it mean by the orbital, and so on. Anyway, so before we go, we end, let's take a picture first. So I just put like this, and then I just this picture. So today I don't have this, so I just do like this lah. Okay, so those who open the camera, please look at the camera. Let me put upstairs. Okay, so like this. Okay, so 1, 2, 3. Okay, so thank you all. So we end our class today with a session of tasbih kafarah and surah Nas.